Good morning, everyone. Today we are going to discuss the topic deadlock in operating system. It is a state of the system in which no process of the system works. That means it is a state what we call is dead state. That means total functioning of the system is zero. Sometimes we call it system hang. When system hangs up, all the processes has been blocked up by the other processes, and that is what we call is deadlock. Then for today we will be discussing about the deadlock problem. Then what is the system model for the deadlock? That means what are the main components that are included in the system which are characterized in the deadlock problem. Then we will be having deadlock characterization. Characterization means we will be discussing about the characteristics of the deadlock, that how deadlock happens in the system, what are the various necessary and sufficient conditions for the deadlock to occur in the system. Then we will be briefly discussing about the methods of handling the deadlock in the system. So let's proceed. So what is the deadlock problem? It is the state in which a set of processes are blocked by holding the resources. For example, you say there are two disks in the system and the two processes are there, P1 and P2. Now see, process P1 is holding the access of disk 1 and process P2 is holding the access of disk 2. But process P1 requires access of disk 2 to complete its execution and P2 requires access of disk 1 to complete its execution. But none of the processes P1 or P2 will be releasing the disk those are acquired by them, because every process is in a rest condition. That means every process wants to complete its execution and none of them wants to release the resources that are acquired by the process. So that is the problem of deadlock. See, we are having a general life example of a bridge. Suppose if there is a bridge, a narrow bridge having the bandwidth of only one directional transportation, then what is the solution for the bidirectional traffic to go smoothly? Obviously, if a condition of congestion is there on the road, then you have to enforce a particular vehicle to get in reverse, and then other vehicles can pass through the bridge. But when if there is a condition of higher congestion, then there can be not only a single vehicle, you may need to roll back more than one vehicles to pass out the congestion and clear the bridge for smooth functioning of the transportation. Same is the condition in which bridge is termed as a resource which is acquired by the different processes. But when a condition of deadlock happens, then we need to roll back the process and we need to preempt. Preempt means to remove the process from the main memory under execution, so that other processes may get their execution completed well in time, and the condition of deadlock will be obviously removed. Now there one more condition arises, that is the Starvation problem. Starvation is the problem in which a particular process is waiting for the execution in the system, but it doesn't get its turn to execute. So that is also a problem. Now, system model for the deadlock situation. So in system model, we are having a number of resources in the system. For example, say resource 1, resource 2 and up to resource M. CPU cycles, we will be having memory space, we will be having input output devices. Each resource type may have multiple instances of itself. That means if there are multiple devices such as printer is connected to the system, there can be one printer, there can be two, there can be 10. So these are the instances of a particular resource that we are having in the system. Now there is a particular scenario of accessing those resources by the different processes in the system, and that is, it is a three-phase process, and means first a process requests for the resource to be used when it needs for completion of its execution. After requesting a resource, it acquires the control of the resource and uses it for its execution to complete, and after completion of its execution the process releases the resource and the resource gets freed and can be used by other processes in the system. Then we are discussing about deadlock characterization, means what are the characteristics, what are the necessary conditions that are leading to deadlock situation in the system. And these are basically four conditions which need to hold simultaneously for a deadlock to happen in the system. So first situation is mutual exclusion. Mutual exclusion is a condition which defines that one process can use one resource at a time. If we can enforce the situation, then deadlock will not happen. But if a resource is being accessed by more than one processes, then it can lead to the condition of deadlock. And second condition is hold and wait. This is a condition in which one process is holding a particular resource and is in the need of another resource for its completion, but it doesn't get that resource. So it is holding a resource which cannot be used by any other process, and it is requesting a resource which is acquired by some other process. So that is called hold and wait. It is holding a process and waiting for, it is holding a resource and waiting for other resource to be acquired for execution. So that is hold and wait condition. Third one is no preemption. No preemption means to stop a process, to pause a process in between the execution before its completion. But if it is a no preemption condition, means there is a voluntary access of the resources in the system. That means a process having acquired a resource can release the resource voluntarily on its condition, whether it has completed the task. Means if the process is acquired with a resource, that process will release the resource at that time only when it gets its execution completed. So that resource will be with the process throughout its execution, and you can say being wasted, because in between the time other processes could use that resource, but the process is not releasing the resource, so is unusable by other processes, so can lead to the condition of deadlock. Last condition is circular